Okay, welcome back to the Dublin Academy Online.com. Okay, so Leaving Cert Ordinary Level Maths, Series 6, Episode 5, Paper 1, Question 1, and my name is Michael Dalton. Now we're going to do approximation and scientific standard form, okay, because approximation seems to be a problem. It came up the last time and we have to kind of get it sorted. But let's have a look at this. 1400 expressed as a multiplied by 10 to the power of n, where a lies between 1 and 10. That means a is greater than 1 and less than or equal to 10. Okay, well we just have to look at how many spaces. Okay, so if I wanted to write that I'd have to write that as 1.4. That's a. Okay, and then I have to multiply by, well, what to get back, how many places did I go? 1, 2, 3. So that's multiplied by 10 to the power of 3. Okay, so that's the answer. Okay, so you got its lowest form. You got it between 1 and 10, and then you multiply by 1000 to give you back to 1400. Okay, now express this in standard form. Now you can see that this is it's quite large. Okay, so this is if I want to make this the same thing, a lies between 1 and 10. Okay, so I have to bring that to 3.72. Now in order for me to bring that to 3.72, how many places of decimals did I move it? So so the point went from went 3, 1, 2, 3, okay, and that's it. Okay, so you see that, so that 3 point there, that point there, 1, 2 and 3. Okay, so that's over 1000, right? Do you understand? So it's a fraction, you remember, a fraction. So 1000 is the same as 3.72 all over 10 to the power of 3, isn't it? Okay, because 1000 is equal to 10 to the power of 3. Okay, and you bring that up using indice rules, which is on series 1. You'll find in there one of the episodes contains this indice rules. Okay, so bringing up the 10, it becomes 10 to the power of minus 3. Now that's an indice rule. The indice rule says anything underneath a to the power of m over a to the power of n. Bring them up and it becomes a to the power of m minus n. So it becomes a minus. Okay, the power becomes a minus. Moving along. Okay, now so that's a standard form. And now we're going to deal with multiplication of all these and adding of them. Okay, so how do we adding standard forms? Right, let's look at the first one's adding standard forms. So we're giving equation 2.64 multiplied by 10 to the power of 2 plus 2.34 multiplied by 10 to the power of 3. Now I can't straight add these, okay? I have to convert them, right? And I usually convert them, and I would convert them so this would be multiplied by 10, so the decimal place would move 2 places to the right, you understand? So this is multiplied by 100, that's 264 plus, and this is moved 3 places, so this is 2, there's the point there, 3, 4, 0. Okay, so you can see that what they worked out to be. Okay, so it's multiplied by 1000. Right, so we add them. So so we put on 264 there, and we add them, and we get 2604. Okay, 2604. Now this is represent 2604 is 2604, and that's equal to 2.604 because a lies between 1. So we know that we have to get it between 1 and 10. So we're given our spot there. So we know it's there, and it's multiplied by 3 places, which is 10 to the power of 3. So it corresponds to the decimal place movement corresponds to the power. Do you see that? Okay, so that's a kind of a nice one to know. Okay, so move 3 places. Right? You can see that. Move 3 places. Right? So you can see that there. 3 places referring to the 3 to the power. Okay, so that's adding. Now with adding, you understand that you have to get them to the same level. Okay. Or you can bring this down. Now another way is I could bring it down and I could add them, you know, I mean I don't have to go and I'll do all that. I could just reduce it, get one to the same power. Okay, so this will be 3.4 multiplied by 10 to the power of 2, and then I could add them. Okay, but you can try it that way and see if that works out. Next is multiplication of terms, of standard terms, multiplication. Okay, so this is multiplication or division. Same way the addition. Okay, they work in tandem. So multiplication. So with the same question again. So I've got 2.64 multiplied by 10 to the power of 2 multiplied by, now it's usually like this, or you could have a multiplication sign, but you know what it means. Multiplied by 3.72 multiplied by 10 to the power of minus 3. Okay. Now, when you're multiplying, you can add the indices. So we multiply this by this, so that's 2.64 multiplied by 3.72, and then we multiply by, we add the powers. Okay, so we got 10 to the power of 2 multiplied by 10 to the power of minus 3. Okay, because we're taking out the powers here. With multiplication, you can do a lot. You can do. It's more flexible. Okay, so this multiplies out as 9.82. Now, what do we do here when we're multiplying by it? We've got the same power and the same base. So we add the bases, and it's 10 to the power of minus 1. Okay, that's another indice rule. A to the power of n multiplied by a to the power of m. So you've got the same a's, so it's equal to a to the power of n plus m. So the same base is 10. Okay, so we add the powers. Minus 3 plus 2 is minus 1. Okay, and that can be also written as 9.82 over 10. Okay, so it's the same as you bring it up and it's multiplied. So that's a fraction form. Okay, and that's how you do those, multiplication and division. Okay, division, you just subtract them, multiply them, and then, or divide them and then subtract the indices. Now we're going to deal with accuracy. Okay, accuracy. A-C-U-R-C-Y, accuracy. To the nearest unit. To the nearest unit. Okay, now this is going to be kind of a... Okay, if the figure after this... I'm going to write this down so you know. If the figure after the decimal point is 5 or greater, 5 or greater, is 5 or greater, greater sign, increase the whole number by 1. Increase the whole number by 1. Okay, now for example 99.567, right? Now let me just talk about here. Okay, so that's we'll just do an aside here. Okay, so when I write down an approximate, somebody says, oh, it's approximately 100. Okay, well that's equal to using this proof or statement or whatever rule. Okay, so this is a rule, whatever rule. The 100 will follow this rule. So 100 could be 99.512, or it could be 104.2. So you see that the error is 1. Okay, you follow that? Okay, so you see that the error is in around 1. Okay, just to let you know, because we had this before when working out approximations, right? So you have to know that your line 5 is the key number here. Okay, so 5 is, everything changes here. This 7 changes this 6 to a 7, and this 7 changes this 5. And anyway, this 5 will change this 99. So it will be 100. The answer is 100. Okay? For example, and another aside, like 10.331 is an approximation of 10. So if 10.31, so the error is 3.31 over 10. Do you understand the true value? Okay, so you have to remember that it's not really 100. So the answer to that is 100, but it's actually 99.54. So there's an error always in this, and the sys comes up and weights and measures, and when you're going into the bank, they'll round it down rather than round it up, or when you're buying something, But so you're always wary of that fact. Okay. So we're going to go along. The next one is decimal places. Decimal places. Decimal places. Right, okay, so just going along with these, I've got number 8.3294, and it says express that in 3 decimal places. Express in 3 decimal places. Okay, so you would express in 3 decimal places, it'd be 8.329. The 4 doesn't change the, see the 4 doesn't change the 9 because it's less than 5. Okay, so it's there, it's 3 places. Express in 2 places. Okay, 2 places of decimals. 2 places. So you've got, the 9 will change that to a 3. So you got 8.33. Okay, so that's 2 places. And then you've got the 1 place, and you see that the 3 cannot change the 3 because it's less than 5, and the answer is 8. Okay, so the error is 0.329 over the true estimate, which is 8.329. Okay, not the rounded estimate. It's the true value all the time, or the approximate value, like the true value or the estimate value. So that's decimals. Now we're going to significant places, or significant figures. Sorry, significant figures. Now you will be asked to put in significant figures or decimal places. It always comes up. So I have to go through this because if I don't, you won't. It will be a little bit disturbing when you come across it. Now, let's have a look at this. It says put that to 3 significant places, significant numbers. Okay, figures. Okay, so the significant figures here with 3 significant figures. This 4 doesn't change this 9. This 9 changes this 2 to a 3, and then we're left with 833 as 3 significant figures. For 2 significant figures, this should be 8.3. 8.3. That's 2 significant figures. And then that's 3, and this is 2 significant figures because we got 8.3, and then we got 8, which is up to 1 significant figure. Okay, so which 1 significant figure, not decimal places here. Okay, let's have a look at another one. How can this here is it? Right, so let's have a look at this. 38443. Now, remember that it's 5 or upwards changes the preceding number. Now let's have a look at this. So how many significant figures have we got here? We've got 1, 2, 3, 4, 5, 6 significant figures, and it's 384,493. And someone says, yeah, well, give me that in a 3-figure sum. Okay, so you would look at this and you say, okay, well, I'm going to do it right now here. This 3 doesn't change this 9. This 9 changes this 5. That's 384,500. And that's 4 significant figures, and this 5 changes this 4 to 385. Okay, so you see what's happening here. That's 3 significant figures. Then you got 2 significant figures. That would be, that 5 would change that to a 9. That's 390. Okay, so see, so the 384,493 to 3 significant figures becomes 390,000. So you have gained plus 5.6 thousand, 5,600. Okay, I think. Yep. Okay, yeah, that's it. You know, it's actually 4,600. But anyway, but you get the message here. You know, you just take the one away from the other, and you see what's the difference. You're not really asked the difference. I'm just going through this one with you. So, okay, 0, 4, 6, 1, 5. Okay, so it is 5,000. 5. Right, 5,600 is the gain here, right? Okay, so it's good to mess around with these figures, and it's good to get to know them, and it's good to be able to move the decimal places, because, you know, in reality they do be asked. You know, they don't want to be messing with numbers, with small numbers, especially when you're dealing with large purchases. Okay, so you have to be wary of that. The questions. Right. Now, express the following in the form of a multiplied by 10 to the power of n, where a lies between 1 and 10, and n is an element of z, which is an integer. Okay, it's a whole number, plus or minus. Now 3.48 multiplied by 10 plus multiplied by 10. Okay, so we have to make them out and then multiply them out. And then add them. Okay, so you have to get them relative. So this is going to move 3 places, so it's going to be, and then you add this. Okay, multiplied by 10, 67. And this is must multiply. This is subtraction actually. So that's minus 9. So this is that. Okay. Now you know how to do subtraction, the same as addition. Now this is multiplication. You know how to do these. These two here are multiplication. 1.8 multiplied by 10 to the power 2, 4 by 10 to the power 3, 3.7 multiplied by 10 to the power minus 1, minus 2, 1.2 multiplied by 10 to the power minus 2. Rounding off the following to 3 significant figures. Okay, 3 significant figures. Now that's 0, okay, remember that. This 0 is going to give you problems because it's not a significant figure. So 3 significant figures will be 0.0777. I answered the question for you. Express 2 and 1/12 as a decimal. Divide 12 into 1 and then 2 point whatever it's going to be. 2 point, it's 1/8, 1/12, it's 2.8 I think. So it's off to, so round as a decimal to 2 decimal places. So whatever you get here, you round it off to 2 decimal places. Right, now I hope that's going to be grand. Now before I was talking about adding, you know, when you have 2 multiplied by 10 to the power 2 plus 3 multiplied by 10 to the power 3, well I can change that 2 multiplied by 10 to the power 2 plus 30 multiplied by 10 to the power 2. Do you see what I've done? Now they're both the same and I can add them. You follow? Once the powers are the same I can add them. That becomes 32 multiplied by 10 to the power 2 plus 2, which is the same. We're not adding them here, we're only adding them, so it's 32 multiplied by 10 to the power 2. Okay? Thank you very much. I hope that works out for you. Bye bye.